I'm here. Yeah, mommy's calling. Yeah? Mommy's calling. I'm coming.
Okay. Guys, please give me 5 minutes, okay? Let me check up on some people.
Hello.
Hello. We'll start very soon, okay? Please give me 5 minutes. I'm checking up on some of the students who are not here, okay? Please know that this is for those doing electronics, okay? So if you do electronics with me, you are supposed to be in this class, okay?
I'm gonna try. Roger is in the waiting room, so can you let him in?
Hello.
Wait, Sean's part of this class too.
Yes, Sean is part of electronics.
Yeah? Uncle Triumph.
Yes.
My brother's microphone is broken. So
Okay.
you have
But
to
can he hear?
ask me the questions and I'll tell him.
No problem.
Okay.
If he can hear, that is fine. I think once you're this thing, because many of us or many of you are not going to talk, you basically show your work.
Okay.
Stuff like that. Okay. Okay. Roger says he can hear. So we should be fine. Okay.
I can hear myself from upstairs. Hello.
Talking, Damien. Who's do?
And please, who is do? Hello, who is do?
And your mic on.
Is do or Himaba? Who is do? Okay. I'm calling one more person and then Start. Okay. Ora. And Ohimaba. Okay. Ohimaba, please, Ora is not supposed to be in this class. Okay, because he has not started with electronics yet.
Okay.
Hi. Okay, guys, let's start.
Uncle Titi,
Yes.
I'm calling you, please. My brother wants to ask you a question.
Let him ask me from here. Eli, what's up?
We have a class on Friday.
No, not this Friday. But today is Friday.
Yeah, today is Friday.
Of course.
Eli,
Why?
your
Yes.
group will soon meet, okay? Your
Friday.
your group will also meet, so I'll let you know when your group
He
is
has
about
a
to meet.
group? Which
Yes.
group?
Eli too has a group now.
So I'm guessing he's the driving force.
Okay, guys.
I don't want to be in a group with some people that I don't know.
Okay, so please, we are continuing from where we left off last week. Last week I told you guys to do something for me. Did any of you do it?
I did it.
Hello?
I did it.
Okay.
I am a God.
Okay.
Gosh.
Okay. Today is Ohimaba's first time in this session. Our first session was last week, okay, as an electronics group. And this is our second session.
So welcome.
So, Ohimaba, you are officially welcome. Some of them have not come in yet. Maybe they'll come.
When you say officially, do you mean as in paperwork official or?
No, this is her first meeting with you guys. As in, you guys
When
have
you
not
said
met.
official, it was like it went through a lot of processing and everything.
Oh God. Okay, let's talk. Okay, so let's start. The first thing I asked you guys to do was to tell me 5 differences between the Arduino and the microbits. That was the assignment. So we'll start from Ajwa and her team. Ajwa and her people.
Titi.
Yes.
Titi. Petra said that she's joining.
Yeah, I can't see her here yet. So I don't know.
Uncle Titi.
Yes.
This particular part, the electronics part, is there any competition for it?
Yes, actually there was a competition.
Physical competition, not virtual.
Yes, there was a competition this year, but I didn't enroll most of you. I thought you weren't ready. So it's still ongoing, but I thought you guys weren't ready. It's one of the reasons why I've decided to create different groups so that.
Wait, Titi.
Yeah.
So you're saying that you signed us up for a competition
No, I didn't.
With people in college, but you didn't think we could do electronics?
Yes, because most of you hadn't gotten far with your electronics programs. Do you get me? And you know, electronics is such that it requires a lot of knowledge. So if you don't know, you don't know. It's not like coders Z that they are giving you instructions. This one you're supposed to create something from scratch. Do you get me?
Wait, so we create our own Arduino board. We create our own LED to code that.
No, you create your own projects depending on the project you come up with.
Oh, okay.
Yeah. So
Makes a little sense.
let's pick it up from here. So as I said last week, okay, I think Kofi is here. Okay, Kofi is here. So those sending messages. I don't know anything. Please help me.
You can see our messages.
Yeah, no. So let me give you guys a review of what we did last week. Okay. I'm going to give you a review of what we did last week because most of you weren't in the class last week. So after the review, then I'll have you guys submit your, tell me the differences between microbits and Arduino, and then we continue from there, okay? So last week, we were talking about microcontrollers, right? And I was telling you guys that there are different types of what? Microcontrollers. There are so many types of controllers. The Arduino board is just one of the many microcontrollers out there, right? Then I showed you another type of microcontroller, that is the microbit. Okay, so what you see on your left is the microbit, and what you see on your right is the Arduino. Okay, if you look at the microbit has LEDs on it. So you can see some LEDs. Okay, these LEDs allow you to display things on your microbit. So if you look at the Arduino doesn't have what? LEDs, okay? But the microbit does. So I'm coming. The wire has gone off.
Isn't this an LED?
I'm coming. So as I was saying, if you look at the microbit has what? LEDs on it. The Arduino also has LEDs on it, like this one, this one, this one, okay? But it doesn't really serve as a display. Do you get me? As a display for the Arduino. For Arduino, if you want a display, you have to connect it to something else to display something on the what? Arduino. Or else maybe you have to use your serial monitor. Okay? Those of you who are doing Arduino know about serial monitor. But for microbit, okay, which is what's on my left, you can see that there is a direct display on the screen. So whatever you want to display, you can just display it directly on the what? On the microbit. Okay. So as I was saying, whatever you can use the Arduino board for, it's possible you can use the microbit for. Do you get me? Because they are all what? Microcontrollers. Then I explained that a microcontroller is just like a CPU. It's the brain of a computer. Okay, so you can build a robot with an Arduino. Okay, you can build a robot with a what? With a microbit. Please, are you all following? Okay.
Yes,
so
please.
Basically, what I said was that I wanted you guys, or last week I said, I want you guys to go and find out the difference. What are some of the differences between a microbit, a microbit board and an Arduino board?
Okay.
We know that they are all microcontrollers, but what are some of the differences that you can see about them, that you can find about them? That was the assignment that I gave. So quickly, I just want us to run through, at least give me maybe 2 or 3 differences, okay?
I have
Between the what? Between the Arduino board and the microbit. So we'll start from Ajwa. Ajwa, just give us 2 or 3 differences. You and your team, okay? You and your squad over there. You, Kwesi, and Nana. Give us 3 differences between the microbit and the Arduino board. Okay, let's go.
There's lights on the microbit.
Okay, if you say lights, you've not said anything.
Um, what I mean is,
Okay. The microbit has its own display, right? You are talking about a display.
Yes, that's what I meant to say.
Okay, where you can display things, okay? And the Arduino board
Yes.
doesn't have its own display, okay? So that's point number one, okay? So point number one, the microbit has its own display, the Arduino doesn't, okay? Second, you can tell me something else about the microbit, a difference between the microbit and the Arduino.
I can.
Ajwa, no. I mean, I'm with Ajwa and the people. Please, let's hurry up, okay? The time is short. Our time is
The connection of the microbit is direct, whilst the connection of the Arduino is through wires to the LED.
Are you sure? The connection of the microbit is direct. What do you mean by direct?
Yeah.
And the connection of the Arduino is through wires to the LED. They all require wires. If you are connecting a microbit to anything, you require wires, right? If you are connecting an Arduino to anything, you require wires. So that one doesn't really pan out. Okay, Kwesi, please help us. Difference between microbit and Arduino. What are some of the things you see? You guys have used the microbit a lot. Nana and Kwesi. So if you look at it, what are some of the differences? Like that, what are some of the things that you've done with the microbit that you don't see the Arduino?
The microbit is smaller than the Arduino.
The microbit is smaller than the Arduino, and they have to do a size comparison. For this one, we have three types of Arduinos. Okay, we have the Arduino Uno, we have the Arduino Nano, and we have the Arduino Mega. So even with that, it can change. So here, visually, the microbit is smaller than the Arduino, but that is not really a difference. You get me? That is not really a difference. What else can you say? You can even talk about the pins.
It has, I was going to say that. It has pins. No, it has, the Arduino has analog pins, whilst the microbit doesn't have analog pins. Yeah, it doesn't have analog pins.
Okay. In a way, so I'll accept that. The Arduino has, the Arduino has separate digital and what? Analog pins, right? But the microbit doesn't have separate digital and analog pins. Please, you understand? So, with Arduino, if you want analog pins, you know where to find it. If you want digital pins too, you know where to find them. But with the microbit, they've been mixed. Do you get me? So it's not as straightforward as the Arduino. Okay, I'll explain that later, how to find the analog pins on the microbit. But just know that it has analog pins, but it's mixed with the digital pins. It's not like pin this is only for digital or for analog, but one pin can be used for what? Different things. Okay. Do you have last one? Then we go to Petra. Do you have any other difference?
No.
No, you people. Okay, Petra, please give me two differences between the microbit and the Arduino.
The microbit has more buttons.
The microbit has more buttons. That's very true. The microbit does have more buttons because the microbit has like 3 buttons, right? Button A, button B, and the reset button behind. Okay. The Arduino board has only what? The reset button. So that's a good observation. What else?
The the microbits only has 3 pins.
Microbit only has 3 pins. Not necessarily. The microbit has, okay, well, it depends on how you look at it, but it has 4. It has a pin 0, pin 1, pin 2, pin 3, and pin ground. These are all pins. You get me?
I thought it was 3 volts.
Yeah, that's 3 volts. Yeah. So the 3 volts pin, the ground pin, pin 2, pin 0, and pin 1. But then, yeah, you can say that the microbit has 4 pins or even 5. It depends on the way you look at it. But that's fine. Okay. So point well noted. But the Arduino has quite a number of pins. Okay, but let me just add this, that the microbit pins can be extended. Okay, for those who are doing microbits, you will see that there's something called the expansion board. Okay, when you put in the microbit, it gives you more pins, right? As many pins as you can get on the as many pins as you can get on the Arduino. Okay, so the microbit has a way of having more pins. Just know that. Okay, so the pins are not limited to just these pins that you can see here. It has a way of having more pins. Okay, Ohimaba, please talk to us.
So the difference between the Arduino and the microbits is that I think the microbits is smaller and more about the security of whatever it's put in.
Okay, the microbit is smaller and more about whatever it's put in. Okay.
And then I think the Arduino focuses on like the ability of the board, which makes it look more old.
Okay. Okay, that's fine. It's not really clear what you're saying, but then even though, let's keep in mind that even though the Arduino board looks more robust, or you get me, or more stronger than the microbit, the microbit and the Arduino board do very similar things. Okay, they do what? Very similar things. And let me add that the microbit actually has sensors on it that the Arduino board doesn't have. Okay, so the microbit has a tilt sensor on it. It has an accelerometer on it. It has a temperature sensor on it. Okay, so this means that you can do a lot of things with a microbit that you cannot even do with the Arduino board. Okay, so let's say if you wanted to use a tilt sensor with the Arduino board, you would have to connect a tilt sensor to the board first. But with the microbit, there's already a tilt sensor in the microbit, which you can directly program. You get me? So what you said is true, but there is still a lot of
so all in all, the microbits is more advanced than the Arduino board.
Not necessarily. No, not at all. They both have similar capabilities. Okay, they both have similar capabilities. I won't say that the microbit is more advanced than the Arduino board, but I will say that the Arduino board is more robust or stronger. Do you get me? It is way stronger than the microbit. The microbit can easily blow. You get me? The chips on it are not very strong and all that. It's durable, exactly. One, it's more durable than the Arduino board. Okay, it can perform more robust functions than the Arduino board, and it can also take more complicated code than the Arduino board. But in terms of what they can do, both can fairly do a lot of things. Okay, Okay, so today I want us to delve deeper into the connection, okay, into the connection over here, and then we'll all do the connection, and then you show your connection, okay? So I need you all to open your Tinker card.
I've done everything.
Open your Tinker card. We are going to start, we will start with the microbit, okay? When we are done with the microbit, then we'll go to the Arduino board, okay? So I'll open a new Tinker card, this thing. So let me first explain the circuit, okay? So the circuit is pretty simple on the microbit. We have the potentiometer. Please, you all know what the potentiometer does?
Yes.
Okay.
Yeah.
So we have the potentiometer, okay? Someone, let me see. Okay, I think someone doesn't know what the potentiometers are. So let me quickly do a recap, okay? Okay, so the potentiometer is like a resistor, okay? But it's a variable resistor in a way that as you turn the knob, okay? Do you see this knob? As I turn the knob, the resistance reduces. Please, do you see? As I turn the knob, the resistance reduces. And as I turn it back, the resistance will increase, okay? So as the resistance reduces, it means that more current will flow through. Do you get me? Hence, that's why as I turn the knob, you can see that this LED is getting brighter, right? The LED is getting what? Exactly. So it's like a controllable or resistor. I like that word a lot. Okay. So it's like a resistor that you can control. Okay. You can turn it so that more current will flow, or turn it the other way so that less current will flow. So here you can see that as you reduce the resistance, the LED is becoming brighter and brighter because the current flowing through is becoming what? More and more. Okay. Okay. Then I will show you how come as we turn the knob, okay, the lights on the microbit also what? Increase. Okay. I'll explain that to you in the code. That's purely the code doing that. Okay, so it's a controllable what? Resistor. And the way it's connected is simple. It has 3 pins. Okay, one pin goes to ground, the other pin is the controller. Do you get me? The other pin is where the control will come from. Okay, that's called the wiper. And then the third pin is the voltage. That's where you connect it to the what? To the power. So one goes to whether pin 0, pin 1, or pin 2, depending on the pin that you are using. Okay, so the middle one, that's the wiper, goes to any pin you want to use. Then one goes to ground, then the other goes to what? The voltage. That's 3 volts over here. Now the LED, one pin will just go to any pin that you want to use to control the what? The LED. Please, are you getting me? And then the other part of the LED will go to ground. Okay, so let's do that right now. Let's go into your Tinker card, bring your microbit. If you cannot find the microbit, just type microbit and you should find it. But you'll find it here. So I'm pulling my microbit. Okay. After you get your microbit, now go get your potentiometer. Please, are we all following?
Yes, please.
Okay. go get your potentiometer. So you go look for your potentiometer. I think potentiometer should be on top. That is it. You get your potentiometer, and then you can rotate your potentiometer so that you have okay. Okay, then go get your LED. Then go get your LED. Where's LED? Here. Then go get your LED. You know how to identify the positive and the negative sides of your LED, right? The bent side is the positive side, and the straight side is the negative side, okay? And by convention, anytime we use a negative wire, we need to color it with black, okay? So keep that in mind. Okay, so what we are going to do is that we are going to connect the negative part of the LED to ground. And then connect the positive part of the LED to any pin that you want to use, okay? Any pin that you want to use to control your LED. I will connect mine to pin 2, but you can use any this thing. Then we are now coming to connect our potentiometer, okay? We know that the wiper is in the middle. The wiper is what controls the resistance, okay? So connect the wiper to, or connect the wiper to any pin you want, but it should not be the same pin that you connected the LED to, okay? It should not be the same pin that you connected the LED to. Then connect the positive side of your potentiometer to 3 volts. Then connect the negative side to ground. Okay, so I'm just going to color my stuff so that I can see it. Okay. Let me give it this.
Uncle Chichi, should I make the resistance for a 250 kilo?
Come again?
Should I leave the resistance as it is?
What resistance? The resistance of the potentiometer?
Yeah.
Yes, it's supposed to be like 250K. Yeah. That's fine. Okay, you can leave it at wherever it is. Usually, your potentiometer should be like 10K.
Okay.
Okay, yeah. So let's change it to 10K. Okay, just so that we are all doing the same thing. Okay. Change the resistance or the starting resistance of your potentiometer to 10K, or the maximum resistance to 10K. However you want to put it. Okay. So I need to do this. Any wire that is going to voltage should be red. And that is it. Okay. If you are done with your circuit, please let me know before we move to writing the code. I want to make sure that we are all following.
Teacher, I'm done.
You're done. Okay.
I'm done.
You're done. Okay. So, Kidi, are you done? Kofi, are you done?
I'm coming.
Ajua, Kwesi, and Nana, how's it going?
Please, you're almost done.
Okay.
Okay, he is done. I'm done.
You're done. Okay. Let's just wait for the rest. Please, the rest, if you are done, please alert me, okay? I don't want to leave anyone behind for the code. Okay.
So we're basically coding this thing to turn. So we're basically coding it to make
Okay.
the potentiometer reduce and increase its resistance.
Yeah. So we are programming it so that as the potentiometer, as we change the values of the potentiometer, the brightness of the LED will change.
Okay.
And also, as we change as we regulate the potentiometer, also the LEDs on the microbit will fill up.
Okay.
You get me? That's basically what we are doing. No. Okay, so all the programming is going to be in Tinkercad. Okay, everything that we are doing is in Tinkercad. But if you have your actual microbit, you'll be using another app, okay, to do it. But
Also called microbit something.
Yeah, that one is microbit.org. They have an interface that you can use.
I don't have a microbit.
Yeah, I have Arduino.
Yeah, I think no one here has a microbit. I don't think
No.
so. I think Adwa them have a microbit. They have a microbit. Yeah, but apart from them, no one has. So they can try it on their own. But for now, we'll just have to do it virtually. Okay.
Show off.
Yeah, maybe one day we'll have a workshop for all of us, and then we can meet them. Maybe one day. Okay, Kofi, please, are you done? Are you done with the circuit? Hello? Kofi, I can't hear you.
Who's Kofi?
He's someone you guys haven't met yet.
Yeah, I'm done. Wait, please,
You're
can
done.
you hear me?
Yes, I can hear you now. Yeah, I couldn't hear you at first, so I can hear you now.
Okay.
All right, awesome. Okay, so now that we are done with this, we need to go to the code, okay? So
yeah, let's move quickly.
As I said, there are two things that we're trying to do. The first thing is we want to fill up the. So if you click on your microbit and you click on your code, something like this should open. Okay, we are going to use code blocks to write the code. When it comes to microbit, Tinkercad doesn't have a syntax part yet. You get me?
Okay.
So it's just code blocks for now. But once you gain the understanding, that is the most important thing. Okay, you get the details of the code as we go along. Okay, so whatever code we are coming to write, we want that code to run forever. So you leave the forever block over there. Now, basically what we want to do is that we want to plot a graph, right?
Yeah.
So
I think you have to go to the output section to do
click
that.
on output. Yeah. So when you go, you click on output, then you take plot. Okay. Plot a bar graph. Okay. Now, I don't know whether most of you know what a bar graph is, but I don't really want to explain what a bar graph is. It's just a way of representing data or amount.
It's a graph that's like bar.
Yes, it's a graph that's like a bar, okay? But that doesn't really explain like what a graph is at the end of the day. But a graph is just a representation of data, okay? So basically,
this one is just in a bar form.
So basically what we are saying is that, okay, as the number of current increases, okay, we want the bar to increase as well, okay? And the bar is what we are using. That's what we are using the LEDs on the microbit for. Okay, so the LEDs on the microbit are what? Acting as what? As bars. Please understand?
Yeah.
Okay. So what are we plotting? Okay, what we are plotting is the amount of current that is flowing through the potentiometer. Okay, that is going through the potentiometer. And that is also the what? The analog values, right?
Yeah.
Okay, because
let's make it like plot 0 to like 360.
Anyway, I'm coming. Because digital values is either 0 or 1, right? But analog values will range from 0 to as far as it can go. Okay, so
Yeah.
put your plot bar graph here, and then go and look for your read analog.
Okay.
Read analog, okay? Because the signal that we are getting from the potentiometer is not a digital signal.
Yeah, it's analog because you can continue changing and twisting the wiper.
It's as if you are using the photoresistor, okay? You are going to be getting what? Analog values.
Analog values.
Yes.
Move from place to place.
So you are going to say read analog values. Now you need to tell it where to read the analog values from. Mine is from pin 1 because I connected my wiper to what? To pin 1.
Pin 1.
Right? But please, based on where you connected your wiper, if you connected your wiper to pin 0, make it pin 0. If you
let me just say one thing. The wiper is the thing in the middle.
Yes, the wiper is the middle terminal. The wiper is the middle terminal. Please take note. Okay, so I connected mine to pin 1. So please make sure you select based on what you connected yours to. And we want it to move from 0 to, okay, you can use any number, but we are going to use 1023. Okay. Did you get me? That's the value of the current. The value of the current going through a 10K potentiometer ranges from 0 to 1023. Okay?
Okay.
The value of the current going through what? A potentiometer ranges from 0 to 1023. Okay.
Okay, let me do this part of the code and we'll move on.
Now, once you have this, you are able to read your what? Your analog values. And you've told it that, okay, it should, the graph should be from what? 0 to what? 1023. Who wrote on my laptop? Who did the black mark? Please, whoever did the black mark on my laptop, please clear it. Someone created an annotation. I think you were pointing at something, so please.
Yeah, it wasn't me though.
Please clear it.
I'm coming. Let me erase it. No, I can erase. Like you can erase anything.
So you just clear off.
Just click on clear all my drawings.
I can't erase it. It's only the person who did who can erase it for me.
I was trying to do something.
So it was Petra.
Okay.
But I made a mistake and left the meeting because of the internet. So now I can't erase it.
No, I've erased it. Please, which pens can't you see? Remember, which pens can't you see? I'm not clear on your question. The second pin.
One
pin on the potentiometer or on the microbit? Or in the code? I can't seem to. So if you want the pins in the code, click on the, you see, there's pin 0, pin 1, and pin 2. Please, can you see?
You see that one that they've written P1 or
when
P0?
you've written the read analog pin P1 or P0, you can click on it and then you can select based on the pin that you used. You select
the
it.
Wi-Fi is the middle terminal.
All right. So that's cool. Okay. So now we've programmed the bar graph. Okay. So it will display, it will use our microbit LEDs as our graph. Now, the next thing we want to do is that we want to control the LED based on the amount of current going through pin 1. You get me? Mine is pin 1. Yours might be another pin. So I want to write a code that will say that, okay, send analog signals from pin 1 to pin 2, because I'm using pin 2 for my LED and I'm using pin 1 to what? To get my what?
That kind of current thing.
Analog signal. So I'll look for something like write analog. Exactly.
Yes, there.
So I'll pick this. Okay. So so I want to write.
I can't see all of the code.
All of my code. Can you see it now?
Right, analog.
Yes.
Okay. So basically, you are saying write what? Analog pin. Write just means that sending signal. Okay. Read means that reading the signal. So we can have read analog pin, and then we can have what? Write analog pin. Okay. And then we can have read digital pin, and then we can have what? Write digital pin. Okay. So writing means sending a signal to the pin. Okay. Reading means reading the signal from the pin, right? So if I say write analog pin, it means that so here I'm sending a signal to pin 2, right? So
yeah.
I'm sending a signal to pin 2. So I'll say write analog pin 2. Okay. Now what signal am I sending to pin 2? I'm sending the signal that I'm reading from pin 1.
Yeah.
Did you get it? So I can just duplicate this same thing that I put in the first one and then drop it here. You get me? So write analog pin 2, send a signal to pin 2, P2. Do you get me? And to what extent do I want to send that signal? Okay, do I want to send a 200 signal, 400 signal? Okay, but I want to send the same signal that I'm reading from what? Analog pin 1.
Yeah.
Please, you guys
just asking what? Okay, Uncle Cham, Roger wants to know which. Wait, Roger, come. Let me show you. And just come. Let me show you. Hurry up. The crooked one goes to any pin 1, pin 0, or pin 2, and then the straight one goes to ground. You understand?
The crooked one is the positive terminal. The straight one
is the positive. The straight is the negative.
Terminal. Okay, so
the straight one you connect it to ground, and then the positive one you connect it to pin 2, 1, or 0, any one you want. Pin, it has to be pin 0, 1, or 2, any one of them. You understand? Okay.
Okay, so now if you are done, you can now run your simulation.
Run my simulation.
If you run your simulation, you realize that you should be getting your bar graph should be reducing when you are reducing when you are changing the value of the potentiometer. So as you increase the potentiometer value, as you decrease the potentiometer value by turning it to the right, okay, that's as the resistance goes down, the current will increase and the bar graph will also increase.
Uncle Tram, how do I twist my thing when I'm using this mouse pad thing? It's not turning.
You first have to run the simulation. Are you running it?
Yes.
Yes. So
and the thing isn't moving anyhow. Is that moving some microbot thing or?
No. Don't touch the microbit part. Touch the potentiometer. The potentiometer is what you are regulating.
Yeah, but I'm touching it now. It's not moving.
Are you touching it from the line? There's a line on the potentiometer. That line, that is the regulator. That's what you should be turning. You click on it and you move it like in a circular motion.
Can you come in? Okay. I don't understand.
If you don't, I'll look at it. Okay.
Uncle Giant, please, I tried it and it worked.
Okay. Awesome.
Wait, Uncle Trump, are you using a mouse? I want to see how you rotate it.
No, I'm using my keypad. My laptop keypad.
Can I see how you rotate it if you don't have a mouse?
I don't know how I'll show you how I rotate it because I'm just rotating it with my keypad. I'm not using any, there's no special.
Why did I get my mouse lost?
How do you rotate something? Just click on it and you are drawing a circle. Click on the line on the
that line, not the space.
What space? What space are you talking about?
Never mind.
There's a line on the potentiometer. Is it working?
No. Let me put it directly in the middle.
No, hold the line. Hold the tip of the line. And then rotate it.
No, it's not doing anything.
Okay, please. Whose is working? Whose is working? If yours is working, let me know.
Mine is working.
Okay.
This mouse is not good.
Okay, Petra's one is working. Address one is working. Or member's one is working. Who else? Please, if yours is working, just send me a message that mine is working. Okay, so that I can know. Just say mine is working, so that I can know yours is working. Okay, wow.
That's classic.
Okay, whose one is working? Who else one is working? Sean, is yours working?
Yes, that's what Sean is obviously working. Okay, some kind of minor electronic waste. Hello?
Sean, is yours working? Sean seems to have left.
I think he just went off. Oh, he's still here. No. Man.
Okay. KD, is yours still not working?
I'm still trying this thing.
Okay, share your screen and let me help.
Okay, I'm coming to share my screen. You disabled participant.
Sorry. Share your screen and let me help you.
Okay. So you said I should put this mouse cursor on the tip of the line.
Why is your microphone blowing?
Oh, I haven't touched anything. So I'm putting it on the line. I'm pressing.
So rotate. Now move.
Yeah, it's not moving. It's not moving at all. The only thing I can seem to the only thing that I can move is this. This thing. It's the only thing I can move.
Yeah, that's the right.
On, let me increase the thing. And on the area of the circumference and the mathematical method divided by the half the circumference is not moving.
Okay, refresh your like your thing. Refresh your browser.
Okay.
Yeah. The tab.
I'll just reload it.
Okay. Sometimes it's just an error.
Okay, let's see what it's gonna do now.
So, no, don't move it yet. Run the simulation.
Start simulation.
Okay. My problem is blasting. Oh, okay. Click on the. I'm coming. Stop the simulation.
Yeah.
Click on your potentiometer.
Okay.
Okay. You see, your resistance is 10 ohms. It's supposed
Okay.
to be 10 kilo ohms, not 10 ohms. 10 k ohms.
Okay.
Okay. So now run your thing again. Okay. So now you can regulate it. Okay, because it was 10, so there was nowhere for it to go. Basically.
Okay, so let's see.
Click and then move.
No, still not coming.
What is wrong with your work? Okay, give me control.
Sure.
Give me control. Let me see.
Give remote control to Uncle Triumph.
Let me see what's going on with you.
It just won't rotate. I don't get it.
If I'm able to rotate it, you owe me 1,000 Ghana cedis.
Sure. And if you are not,
I don't owe you
1,000
anything.
cedis.
I don't owe you anything.
It's not moving. It's not moving.
Yeah, for some reason it's not moving. Let me see.
Delete it and get a new one. Maybe it's broken.
It's broken.
It's not talking to me.
That is very possible. I'm coming.
My code is perfect.
Okay, also use
My code is perfect.
Okay, I'll try it again.
Let's see. I'm not even touching my mouse pad or whatever.
What's up with this thing? Okay, let me do it.
Delete it and get a new one.
My hardware got rearranged. Okay, it's back.
Yeah, I brought it back.
Yeah, I think you have to run a simulation. Oh, wow.
I don't know why it's feeling like that. Please, are we all finished now? Like writing the code and doing everything.
I finished that long ago.
Yeah, I know. I mean, the rest who Kofi, please, have you finished yours? Is yours working? Wow. This is okay. It's possible that the position of this thing. Okay. I'm sure that the position of the potentiometer and what is under, it's interfering. So it can't tell, it can't really tell what you are trying to move. Let me reposition this.
You can stretch it or do anything, nothing's gonna happen.
Well, have you done all that?
Yes.
Hey, so what's wrong? This is super weird. You see. It was the position of the potentiometer.
I don't have 1,000 CDs, please.
It was with the rest of the buttons. You know, these ones too are movable. That's the temperature of the microbits and stuff like that. So it thought that you were trying to move these ones instead of
how dare it misjudge my commands. Let me try to move it now.
Instead of the potentiometer. So.
Let me try to move it. You're having too much fun.
But right now, yours is easier. Anyway.
Let me see.
So I think you can stop sharing your screen now. I'm done with
you. Stop share. Wait.
Okay.
Stop share.
Okay. So is everyone fine now?
Roger said he wants to share his screen.
Roger, please let me see yours so that
share your screen.
I help you, and then we are out of here. Okay. So Roger is the last person. Then we are done. Hey.
Oh my God.
Roger, what happened to your work?
Oh.
I don't even know where to start from. Roger. I don't know where to start from to correct
it.
Who is Googling what?
No, Roger's redoing this other one. That was it's microbit. Macrobit. Microbit. I still don't understand why it's not called a microbot.
Why is not called a micro? No bot.
It should be called a bot.
No bot. A bot is like an
No, we're
intelligent.
not using Arduino.
A bot is like this, that intelligent thing. Okay. Okay. Hey. Take your time. Zoom out. Okay. Zoom out. Okay. You. Oh, take the potentiometer there. Take the potentiometer there. Okay. Rotate the potentiometer also. Okay, so now connect the LED. The straight part goes to ground. Now, the way you're connecting it, see, you have to connect it to the terminal. The terminal will show red. So when you take it there, look for that red thing. Then you connect it. Then you connect the positive side to any pin that you want to use. No. That is too far. So just connect it to pin 2. Okay. The fact that I said any pin, just look for the closest pin to you. Then the middle one is the wiper. So connect it to another pin. So you can connect it to pin 0, fine. Or pin 1, anything. Then one should go to the 3 volts. The other should go to ground. Okay. Now color off is ground black and all your 3 volts red. Your 3 volts should be red, not the other way around. All your 3 volts should be red. The pin can be any color, okay, apart from red and black. Apart from red and black. Okay. So you've done the connection. Okay. Now let's go and write the code. So the first code you want to write is that you want to, inside your forever, okay, you can throw away the start. You can throw away the on start. Inside your forever, you want to write a code that will display a graph. So plot bar graph, okay? So what are you plotting? You are plotting the analog values that is reading from the potentiometer. So read analog values. And what pin is reading your analog values? You used pin, I think you used pin 0. So pin 0 is reading your analog value. So that's it, okay? And then it should be from 0 to 1023. So add 1023 at the end. No. Extend your thing. Some part of the code is hidden on the right side. So you need So
I'm coming.
Write 1023 there in the space. Back 1023. Okay, so now you've written the code to display your bar graph. Now you need to write the code that will change the brightness of your LED. You get me? So you're looking for right analog signal, right analog pin. Yeah, that's what you're looking for. So what pin are you controlling? You are controlling pin 2 because that is what is in your distance. So change the P0 to pin 2. And where are you getting your no, don't throw it away. I can tell you are kind of lost, but let's do this because time is gone. You see, you are sending the please wait there. Where did that wire go to? Okay, you are sending your analog signals to what? To pin 2. So that P0 there needs to change to P. No, not that one. No. Right analog pin. Right analog pin. You are sending it to pin 2. So the P0 there should change to P2. The P0 should change to P2, right analog pin P2. That's what it should say. Currently, it's saying P0. Roger, what's going on? You are taking all the time. Hello, Roger.
TT.
Can you hear me at all? Hello? Yeah, Sean.
Are we going to?
We are actually done. Okay, so we'll be closing soon. I'm just trying to help Roger. Okay, Roger, I can't hear you. Let Damien finish it up with you, okay? He understands it now, okay? I can hear you, but my mic is broken. Okay. So I was saying that the P0, right analog pin, P0, right analog pin. Can you read the right analog pin, P0? The P0 should change to P2 because you are sending the signal to P2. Okay, you stop sharing your screen for a moment, okay? And where's Damien? Hello? Okay, please stop sharing the screen, okay? Okay, so that we can listen. Let's listen. Okay. Damien, please help him out to finish it. Okay. It's just these 2 pairs of code that he needs to finish it up. Okay. Please, are we all clear with what we have done so far?
Yes.
Okay. So that's fine. Let me not take any more of your time. Okay. It's supposed to be a 1-hour session. Okay, where we just dive deeper into electronics. Okay, and we just bond as a group and we get better learning. Okay, so thank you all for coming. The next electronics session will happen, I think, later. Tomorrow is for those doing Python programming. Most of you are not doing Python programming, just 2 of you are doing Python programming. So tomorrow I'll be meeting those who do Python programming at 6 p.m. The next time electronics team will be meeting will be, I'm coming, let me just find something. The next time electronics team will be meeting will be on the 15th of January. Okay, so we are not going to meet for a while as an electronics team. As I said, tomorrow, those doing Python programming will be meeting. On the 2nd of January, those doing Scratch will meet. On the 8th of January, all those who do code.org will meet. Then on the 9th
There are a lot of groups that I don't know about.
Yeah, you don't have to know
Wow.
about it. On the 9th of January, all those who do virtual robotics or who are doing robotics in general will. Then on the 15th of January, electronics will meet again. That's the next time we'll meet and we'll continue from there.
Okay.
Yeah, and so yeah, please, the Lego, those who do Lego also is part of robotics. Okay, so the Robo Squad, anyone who does virtual robotics or does Lego is part of what? The Robo Squad. Okay, so you will know. Let me
Robo Squad.
Let me send, please, a second. I want to put it up here. I want to send the timetable here, okay, so that you guys have it, so that you know which group is meeting.
Okay.
I already have it.
Is it on your PC?
Yes.
You sent us a picture.
Yes.
You sent
It
it
says on
yesterday,
my
and I sent it
tablet.
today. I mean, you sent
but,
it last week,
yeah.
and I sent.
How far with the coders? Are we out? Are we in?
Yeah. So and Damien, please, when we are done, please meet me, okay, online.
Right now.
Yeah. Yeah.
Okay.
When we are done, okay, we need to talk. Please, can someone share it here right now, okay? Because not everybody has it.
Okay, I'm coming. Let me do the sharing.
If you have the document, no. I mean, not. Where are you going? I didn't say share your screen. No, I said if you have the document for the schedule of us meeting, share it in the message section, so that
This is it.
everybody can.
Can you guys see my screen?
It's not in Coders. Oh.
Yeah, this is it.
Where is it? Okay. So can you share the picture?
Sure.
Can you share the picture and put it in the message section so that?
I don't know how to do that. So.
No, just copy the file. Copy the file. Where's the file?
I don't know.
Jesus Christ. Who has the file? You guys.
I'm clicking on share.
No, it won't share that way. You need the picture. Do you have the picture?
Yes, this is the picture.
No, the picture as a file, not the picture as an image. Don't send.
Oh, you mean this?
The picture.
Petra sent it. Petra sent it.
You mean something like this?
A link. Petra sent a link. Okay, we don't.
You
need
mean
a
something
link.
like this?
Yes, we need a picture itself. So copy the picture, drag it, and then drop it inside the message section of this, so that people can. So open file.
Oh, I should click on. I'm coming. So drag it.
Open the file location. You might have to open the file location. Hey, why is this difficult for you guys? Open the file location and then send it.
File location.
Click on open file location.
Okay, open file location.
Now drag it to the message section of your Zoom.
To the message. Yeah, copy.
No, you have dragged it into your browser. Don't drag it into your browser. Open Zoom, you get me, and then drag it into
okay.
tab where you write your messages.
So open file location. So let me open my chat. Let me open my chat first.
Exactly.
I can't see my chat.
Go to chat. Go to chat. Okay, because you are sharing your screen. Okay, so you stop sharing your screen, open your Zoom, and then.
Okay, it has come now.
Okay, so please do it quickly and let's go.
So drag you.
Yes. So when he sends it, you can just download it onto your laptop. Okay, so that you know which group is meeting when. So that you'll be ready for the meeting.
Dragging it right now.
Oh, okay. Yeah, so that's it. Okay, please let's download this. Okay, this is just for this is just up to 16th of December. Okay, then I'll send you guys a new schedule for which.
Yeah, please download it before I close the thing.
For which team is meeting when. Okay, guys. So thank you very much.
TT. Can I just say something about the coders?
Yeah.
You said that Team Variety is out.
Yes, so Team Variety is out. I don't know why. I honestly don't know why. So
wait, but my code should have sent both teams because as soon as I got 540, I switched to the other side.
It did. So the code worked for both teams. But the thing is that we play with different teams.
Okay.
So it's possible that the same code, another team will have a better code than that code. So maybe the team that Quick met wasn't as strong as the team that Variety met. I don't know whether that is the reason, but that is the best explanation.
Or maybe they figured out that. Okay.
But when I checked the leaderboard, we are ahead of them.
Yes, that's the thing. So I mean, there are some things I don't understand, but hopefully we'll see what's up later. Okay, guys.
What if we both meet in the final? What are we going to do?
Yes.
But there are only a few people in Team Quick. So they are going to be.
So everyone is in Team Quick and Variety. Uncle Triumph did that for everyone.
Yeah. I kind of put everybody in Team Variety, in Team Quick as well. So we are in both teams.
So everyone is in every team.
Yeah.
So you just have to switch to the other team and switch back and forth. That's what I do.
Okay, guys.
Yesterday, I
thank you very
didn't
much.
see Quick. I only saw one match.
Oh shoot.
Okay.
Have you guys
this might be the last time I'm seeing some of you for the month of December. So I just want to wish you a Merry Christmas and a Happy New Year.
How about a happy birthday to me?
Why? When is your birthday?
24.
Okay, then happy birthday in advance.
Thank you.
What about my brother?
When is
Sunday.
When is Eli's birthday? Sunday. Oh
Sunday.
wow. Okay.
So happy birthday to him.
Okay, then happy birthday to Eli too. I guess I have a question to do. Okay, guys, take care of yourselves. Enjoy your Christmas break.
Bye.
Okay.
Uncle Trump, I'll join right again.
Yeah. So that we can meet quickly. So, guys, please take care. Enjoy your Christmas and Merry Christmas and Happy New Year. Bye.
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 Okay, Mom. Should they leave or you end the meeting?
Okay, guys, we are done here.
So are you going to end it or they should leave?
Oh yeah, I'll wait for them to leave.
Right.
Bye.
Bye.
Bye. I don't think Ohimaba is leaving though. Or Ajwa.
Bye bye. Bye bye. We are done. Merry Christmas, okay? And a Happy New Year.
Yeah, I forgot we're in December. I thought we had to go 2-3 more months to go to the new year. I just remembered that. But I think you have to remove her. I don't think she knows how to leave the meeting. She's still here.
Yeah. She said she can't see us.
Yeah. Let me type please. Please. And you leave.
But why are you on mute? Okay, you let me end the meeting. Okay. So
Can I read?